In this presentation, we shall address 4 aspects of RVP sampling. Firstly, what is RVP? Or to give it its full title, Reid Vapour Pressure. 2. Why is RVP used? And 3. Where is RVP used? And finally, how is RVP sampling actually carried out? Reid Vapour Pressure is used to measure the volatility of hydrocarbon liquids. The test method is described in ASTM D323. This involves heating a chilled sample to 37.8 centigrade or 100 degrees Fahrenheit. ISO 3170 states that the sample is not decanted prior to analysis. This is to ensure light ends are not lost. Equipment manufactured by UK sampling gauges comply with this requirement. There are some practical considerations from using RVP sampling. Firstly, controlling liabilities with a loss of product. This is the light ends. Monitoring the potential for emissions, identifying transport requirements, and maximising profit from later processing. UK sampling gauges sampling equipment is specifically designed to fulfil these considerations. Finally, our equipment is in use worldwide, both on board ship and in shore installations. How is our RVP sampling equipment used? Reliable, accurate samples can be taken using either stainless steel tubes for 2-inch vapor control valves or standard glass bottles. The stainless steel tube has an internal inlet pipe to which the external sampling probe is attached. Different probe types provide for all level and spot sampling. A distinguishing feature of the steel tube assembly is that the filling rate is not affected by the pressure of the liquid in the tank. So, at depths of 1, 10 or 30 meters, the filling rate is exactly the same. The cap at the other end has a non-return self-sealing valve. During filling, the air can escape through this valve. But once the winder attachment key is removed after sampling, the valve prevents the vapour inside escaping. The whole tube, with its sealed contents, can then go to the lab for analysis, without the liquid being decanted. This is in strict accordance with ISO 3170. And ensures the light ends are not lost. The MK7 winder will be used to demonstrate how an RVP sample is taken in practice. The tube is attached to the winder via the key. The tube is then lowered at a steady rate whilst using the counter to monitor the depth of the tube. Owing to the design of the all-level probe, the tube only fills during descent into the liquid. To bring the tube back up, there is no restriction on how quickly it can be wound back in. As per standard operating procedures, the winder knob is pressed to wipe the liquid off the winder tape as it reels back into the winder housing. Once the tube is back in the winder barrel, standard operating procedures are followed to retrieve the sample tube. The tube is unscrewed from the winder key. The tube is now turned upside down so the probe can be removed and replaced with a black cap. How do we know that the tube holds approximately 80% of the volume of the sample, which is a requirement of the regulations? The probe inlet pipe reaches 3/4 of the length of the outer tube, so the liquid should be just above the pipe end. To ensure this happens, the sampler is lowered at a rate commensurate with the depth of the tank. So, for a shallow tank, the winder handle should be turned slower than for a deeper tank, the aim being to have the sampler at 80% capacity just as it reaches the base of the tank. The best turning speed is quickly learned. Even at 2 in the morning aboard ship, operators consistently achieved good samples, much to the satisfaction of the oil company. A special carrying crate is available to carry up to 6 sample tubes. It's good practice to mark each sample tube with a label to show which tank the sample is from. There should be 1 sample tube per tank, so you should ensure you hold enough tubes in stock. In addition, you may need to take 1 or 2 spot samples, so an allowance must be made for extra sample tubes. In the time between the samples being taken and being delivered to the lab, the samples should be kept cool as per ASTM D323. A plastic cooling crate is available into which the tubes can be stored. The crate is filled with iced water, and the tubes are placed inside with the black caps at the bottom. At the lab, the tube is placed in the liquid extractor, with the black cap at the top. Then, the whole tube is rotated to screw the bottom non-return valve onto the extractor spigot. This will open the non-return valve. Not shown here, a thin pipe will be connected from the spigot outlet directly to the analyzer. The top black cap is slowly unscrewed, thereby releasing the vacuum. The screw tap beneath the spigot is turned to release the liquid into the pipe to the analyzer. To take a spot sample, a spot sampling probe is attached. The winder key for spot sampling fulfills 2 functions. The first is to actually hold the sampler, and secondly, to open the non-return valve when the winder is pulled upwards. This must be done gently, as otherwise the probe will close if it's given a sharp jerk. In this demo, you can see that the probe valve is closed by the action of lowering it into the liquid. At the appropriate depth, as measured by the tape counter, the sampler is pulled slowly upwards. This causes the valve to open. Note, sharp jerks shouldn't be used as the sampler will jump up, then settle back down, which will make the valve closed. When the sampler is retrieved from the winder, the key and probe are removed as before, and the tube is sealed with a black cap. Then it's ready to go off to the lab. The 2-inch stainless steel tubes are designed for 2-inch vapor control valves, but standard glass bottles can also be used. As the sampler descends into the liquid, the filling rate is not affected by the outside pressure. Consequently, the sample is extremely accurate. It's very easy to place the bottle into the holder. In this example, the attached probe is for spot sampling. It is lowered into the liquid, then gently raised to begin filling. As with the 2-inch tubes, sharp jerks must be avoided, as this will cause the valve to close. Upon retrieval, the probe is removed, the bottle is capped, and the sample is sent off to the lab. On the running and all level sampler probes, the filling rate can be controlled by turning the adjuster ring. This has the effect of reducing the inlet opening. So, for situations where the speed of turning the winder handle is unable to produce the desired filling rate, for example, due to the depth of the tank or the viscosity of the fluid, the adjuster ring can be used to slow the filling rate down. To summarise, UK sampling gauges provide RVP sampling equipment which satisfies ASTM D323 and ISO 3170 requirements. Accurate and reliable samples can be taken for all level, spot and running samples, both on board ship and on shore. For more information on our products and training materials, please visit our YouTube channel. Simply search for UK sampling gauges, or contact us by phone or email.